Capacitors and DC. DC voltage source. A direct current voltage source provides a constant voltage between two terminals. An external connection between the two terminals will cause a current to flow between the flow of electrons. In a battery, electrons are stripped from atoms on the top plate and head to the positive terminal. This creates a net positive charge on the top plate. The electrons are deposited on the bottom plate. Capacitance. Capacitance is a measure of a capacitor's ability to store charge on its plates. Higher capacitance can store more charge. The equation we use to find the capacitance of a capacitor is seen below. Capacitance is directly proportional to area, inversely proportional to separation, and directly proportional to permittivity. Capacitance can also be solved by the below equation. An ideal capacitor does not dissipate any energy and stores energy in the form of electric field between conducting surfaces. The components of a capacitor. Conductive plates. Larger plates allow greater storage of charge due to a greater area. Separation. The smaller the distance between plates, the larger the capacitance. Dielectric. Effects of a dielectric. The dielectric affects the field distribution between the plates of the capacitor by increasing the alignment of dipoles between the plates, therefore increasing a stronger electric field within the capacitor. This can be seen in Figure 5. The presence of a dielectric allows for a higher charge in comparison to an air capacitor. This can be seen in Figure 6. Capacitors in series and parallel. Capacitors can be placed in series and parallel, however behave opposite to a resistor. When in parallel, they are added similarly to the resistor in series, and when they are in series, they behave like a resistor in parallel. Voltage also divides as current would for resistors. Capacitor in steady state. Once charged, the capacitor becomes an open circuit. Current equals 0, and the circuit is in steady state. Power curve. The power curve of a capacitor is the product of voltage and current as selected instances of time. The energy stored within the capacitor is the area underneath the power curve. Transients in capacitive network. The plates of a capacitor do not reach a maximum charge instantly. Instead, it takes place over a period of time determined by the network. The voltage across the capacitor changes as it gathers charge as the capacitor becomes closer in magnitude to the source voltage E. The rate of charge slows. This period is called the transient period. Once the transient period is over, steady state is reached. Transients in capacitor networks. RC circuits combine resistors and capacitors. The application of Kirchhoff's voltage law gives the below equations. The product RC is known as the time constant, tau, and has the unit of time. Current in the charging phase. Many electrons will flow quickly the instant the switch is closed, then slow down as charge builds on the plates. The discharge phase. If the energy source is removed from the circuit, the capacitor will have the highest potential and hence will discharge its charge, making a current flow in the opposite direction until there is no more charge and no more potential on the capacitor. The below equations calculate voltage and current in the discharge phase.